So this is a network diagram example and a question that I took from fall 2017 exam 1, because they had critical path analysis discussed before their exam 1. Now I'm asking you to stay on it, work on it, and then together in about 2 minutes we're gonna complete the activity and answer the questions. So go ahead. Those of you who are new to this idea, ask me questions. Those of you who have done it before, just get started with drawing, or download this activity sheet that I have for you on Reginet. It's called Critical Path Analysis Activity Sheet. So, am I sharing the right page? Yes.
So is that talk to board 1, where those 2 top boxes, would those be the specific activities that are listed? So like 1, 2, 3, 4, and so on?
Yes.
Okay.
Every one of those goes on a node. So, and I'm gonna do that here. So this is for me, it should change, okay? You have to read this table, set up work environment. And I'm gonna put activity 1, duration 1. Matt, I don't know if your question was this one, but use the numbers because then that's gonna save you time. So task 1 here, task 2 here. I don't write the description anymore because it's gonna take time. We did that in our first example. So, and then we know early start is 0, early finish is 1. Task 2 is taking 2 days.
I have a question for you, Dr. Lai.
Yes.
Since activity 4 is requiring 1, 2, and 3, and activity 3 requires 1 and 2, can we just do for activity 4, it require activity 3, since 1 and 2 are prerequisites? It would make our charts look a little better, and since it would have to be implied that we had to finish that activity because they're included.
Yes, you're right. That's redundant. Yes. Now, what is that called in mathematics? There is a property. If A greater than B, B greater than C, then A greater than C. Yes.
Transitive property, I think.
What is that?
As I said, I think it's called the transitive property.
Yes.
Can you show what 8 is dependent
If assuming that all of them are the same type of dependency, finish to start, all of them, if they are F to S, then yes. And I think the assumption in all of our example has been that, finish to start. Yes, Chris?
Can you show what 8 is dependent on? Cool.
Mm-hmm. I can put T1 because I feel like I get confused with the 2 numbers. Task 2, task. And then this is going to be T3. T4. 5. T6. you work on this with me, feel free to move items around. I'm going to start with Jake. Go ahead, take control of my system, which I will give you. And then task 3, 4, show their durations and dependencies with an arrow, insert shape arrow. So you go up there in insert, menu, insert shapes, you find the arrow. You're moving too fast. And the arrow there. T set depends on T1 and T2. Yes, needs 2 arrows. Task number 3 depends on 1 and 2. Go ahead, put the duration, Jake, for T3. So that's 2. What's the earliest T3 can start? So you look at the numbers before? No. The numbers before, you get the larger or the bigger early finish number from the 2 before this one. So T3 depends on T1 and T2. T1's early finish is 1. T2's early finish is 2. And if you're assuming finish to start, meaning that you're waiting for those 2 to finish for this one to start, then it means that you have to wait till day 2. You get the larger number. EF1 somewhere, EF2, you get the larger number. It becomes early start of 2. Early finish becomes early start plus duration. 2 plus 2, 4. Exactly. Do the same thing for 4. Let's do the thing Nick suggested. 4 depends on 1, 2, and 3. 4 depends on 3 only. Exactly. So duration is T. Show the arrow as well.
Okay, sorry, I couldn't get myself unmuted from sharing your screen for a second there. My bad, Professor.
That's okay.
And you said you wanted me to do 5? Or?
Yes. So 5 duration and 5 depends on 4 only. 7 is the earliest you can start. 7 plus 1 is early finish. EF. Go ahead, arrow. No, show the arrows that represent dependencies between T4 and T3.
Yeah, you want me to put another arrow, right?
2 other arrows between
Other
T3 and T4 and between T4 and T5. I think I'm good. You did 3 of them. Thank you, Jake. I'm gonna go to Nick R. Nick R. You must have control. You do T7, T6, 7, and 8.
So then by this logic, I'm assuming the slack is calculated by late start subtracted by early start, right?
Yes.
I mean, yeah, just make sure.
Yes, exactly. Or late finish minus early finish. So T6 depends on T4. T6 depends on T4. T7 depends on 5 and 6. Perfect. T8.
I have a quick question.
Yes.
Wouldn't the task 3, wouldn't the early start for that be 3 days since it's dependent on both task 1 and 2, and those add up to 3 days, not 2?
But they can be done in parallel. That's the idea. If there is no dependencies between 1 and 2, which I think there is no. Yes, is there a dependency between 1 and 2? No, I don't think they're dependent. I can't scroll up because Nick is working. So T1 and T2 can be completed in parallel. It means that in 2 days, both of them will be finished. T1 will be done on day 1, T2 will be done in day 2. Now your proposition would be correct if T2 depends on T1, because then it means that it has to wait for T1 to finish. But this design is saying that they can start at the same time on day 0. One of them is done on day 1, one of them is done by day 2. The idea of adding them up is only true when you have finished to start dependencies. Here, there is no dependency between the two. So looking at the numbers that Nick R has put here, early start for T7, larger number between T6 and T5, a grade T6 is getting the number from T4, grade T8 is getting it from T17. Perfect. So yes, Jake.
How do you get the late finish? I know how to. I understand how to get the late start, but not the late finish.
So yeah, we are going to talk about that now. That's the next step. So thank you, Nick. This is early start and early finish. We went from the start to the end, and it seems that the earliest we can finish this project is 21 days. So there is this topic in project management called buffering. You can add buffer to the end of the project, but we don't discuss that in this class. So we're going to assume that the minimum amount of time is the exact amount of time that we need. So the minimum amount of time is the length of the critical path, 21. That's what we need to finish the project, and then we're going to finish the project on day 21. So we're going to put late finish for the last task equal to early finish, and for this one equal to early start. So we're going to assume there is no buffer. We're going to deliver the project on the exact same day it can be delivered, which is the length of the critical path. Now I'm trying to understand where the critical path is. Track it with me and then let me know if I'm wrong. I think it seems it's going this way. Or did I? So this one, is this the critical path? This is the longest path. 2, 2, 4, 3, 7, 9, 19, 21. Yes, this is the critical path, Jake. They add up to 21, the duration of activities. That's the minimum amount of time you need to finish the project. And all these highlighted activities are called critical activities. The blue ones are non-critical. And see, there are other paths from the beginning to the end, and they are not going to be the longest one. For example, this one is 1 going to this one is 2, 3, 6, 7, 17, and 19. So not all paths are the same length. The longest one is the critical path. For the smaller project like this, I just could do it with my eye. For the larger projects, you would use a project management software tool. Now, for latest finish and latest start, other than this fact that I told you that we're not gonna have any buffer, we're gonna deliver the project at that time that we get from the critical path. We're gonna scan the diagram from end to the beginning, coming up with the late finish number. So the late finish of a task would be the smaller number among the late start of all the tasks that come after it. So if, and then we're going to practice this. So if task A has B1, B2, B3 after it, B1 has a late start of 3, B2 has a late start of 5, B3 has a late start of 2, you get the smaller number. That's 2 here. That becomes the late finish of your current task, which is A. So you look at what comes after a given task, look at their latest start numbers, and get the smaller number. Because again, the assumption in our paper and pencil activities is that these are finish to start dependencies, and if a task after this one, the latest it can start is day 2, then I have to have this task finished, the latest, by day 2. So let's put this concept that may feel abstract into practice by asking Grant to do 2 of the late finish, latest start by talking, please. Grant, can you unmute and explain what you're doing? Talk. Grant, can you talk as well so Jake and some of our newer members can understand the logic?
Sorry, it's hard to unmute while there. All right. So here, the late finish is 19
Why is that so?
because the late start before or after it is 19.
Exactly. T7 has T8 coming after it. The latest T8 can start is the 19. The latest this one can finish is 19 because the other one needs this one. Yes. And then latest start becomes late finish minus duration.
So that's 9.
Perfect.
And then the late finish for both of these is 9.
Yes, because T7 comes after them and late start of that is 9. So late finish of these two becomes 9. Latest start of this one becomes 8. Latest start of this one becomes 7. Thank you, Grant. I'm gonna go to the next one on my list.
Quick question. If there was a buffer, how is that buffer determined in a professional setting?
Usually people have rules of thumbs, 10%, 15%, 20%, they add to the end of the project. Some people add to the end of their phases. Some people add to each given task if those tasks are complicated. So buffering is a whole new topic. There are different methods for buffering, different rule of thumbs. This is just a very general idea I gave you. So, but most people add buffer, like they never give the length of critical path as the duration of the project. They add something to it. And 20% is something I've heard from some of my colleagues that they really have done this, 20% added to the length that they estimated. Depends on your style, depends on the organization styles. So, I'm gonna go to Matt, the next one on my list. Matt, go ahead, do T, 4, 3, and 2. T4.
No, I've got the thing. Sorry, I wanted to see the durations because I didn't have them written down. So the late finish of this one would be the lowest of the two after it, which is just 9.
Exactly.
And then late start would be the late finish minus its
no,
duration.
it's not 9. It's another number. You look at the latest start numbers.
Oh, I'm sorry, the latest start. Yeah, you're right. Which would be 7.
Yes.
And then that would be the late finish minus its duration.
Durations are written there, Matt. That's the number.
Oh, it's the 3.
Yes.
It's the 3. Okay, so then that would be 4.
Yes.
And then here the late finish would be 4, and then it would become 2 for the late start, and then late finish would be 2 minus the 2, which would be 0. Correct or no?
It's correct. And then go ahead, do it for T1 as well, now that you're on it.
Another quick question. Wouldn't buffering affect the critical path in general because you're buffering additional days into your diagram?
If you add buffers to your activities, yes, it would impact the whole thing. This is, one in mathematics, they usually, or in economics, they teach you the clean version with no complexities. This is the clean version with no complexities. But if you add buffers, usually software, project management softwares, you can specify all those things, and you can specify different type of dependencies, because again, we keep this very simple. This is finish to start. But so you can have start to start with lag, you can have other types of dependencies, buffers, and still it could do the critical path determination for you. But can we do it paper and pencil? Maybe for a small diagram like this, but not for a real project for sure. That would become one of those, I would say, very complex graph theory problems. So they would have algorithms and numerical solutions to come up with the critical path. The software would do that. They wouldn't be able to do it paper and pencil. But yes, it makes everything complex. Match, go back to T1, late finish for T1 is not 0, it's the latest start of the next activity. So T3, exactly. 2 minus 1, exactly. Perfect, thank you. I'm gonna go.
I was looking at, task 2, but that doesn't have a dependency.
That's okay. So Austin, I want you to unmute yourself, show us the slack for non-critical activity. How much slack do we have?
Here would be
Exactly.
1 day. And then the only other one we have would be this one, which would also be a day.
Exactly, perfect. Thank you, Austin. And Jake, your theory was correct. We look at the difference between the two. Ryan, I'm gonna ask you to unmute, answer the next question. So shade the nodes, we've done that. We've done this. What is the slack for task 4, Ryan?
I'm not sure about this one.
Task 4, what is the slack for it? You can be sure by looking at the picture.
I forgot how to calculate it. It's like
The difference between early start or late start.
Oh, okay. So just be 0 then?
Exactly. Ryan, even if you didn't calculate, okay? Even if you didn't calculate early start and early finish, late start, late finish, you would be able to answer this question. Why? Why wouldn't you need to do all this calculation? And sometimes maybe I ask you the question like this on the exam, you even do not need to go through the whole calculation. Nico, I'm gonna go to you. Why would I be able to answer this question even without doing the calculation? Nico, I'm with you. Or maybe you don't need control, you just need to, you just need to unmute yourself and answer the question. Why do I need
which question?
Question number C. Question C, part C.
Because if it's on the critical path, there is no slack.
Exactly. So class, be aware. Maybe on your exam, I'll ask a question like this. And if the question is asking you to think about the critical activities, you don't even need to calculate anything. You can be lazy and still answer correctly. Because if you've done part A and B, if you know the critical path, then You know task 4 is critical activity. There is no slack. So Jake, in some questions, you don't need to even do late finish, late start. Do you have a question? You raised your hand, Jake.
No, I just don't know how to unraise it.
I think I didn't know that. I think you go to participants.
If you just click the raise hand button again, it should lower.
It's okay. It can still.
Oh,
it can still okay.
I'll get you with that.
So in part D, who can answer again part D? For that one, we didn't need the calculation. What about part D? It says task 6 is taking 1 day less. How would that impact your project completion time? I'm gonna ask someone who is here next on my list. So Chris, how would it impact my completion time?
Would it reduce it by a day?
Exactly. Remember, it's critical path. That's the minimum amount of time you finish your project, and the other path was 19. So between 19 and 20, because you're making task 6 faster, you're making the whole project faster. Instead of 21 days, it's gonna take 20 days. So this is an easy question, but it could be complicated. So if I asked you task 6 is taking 3 days less, then it would make the length of this path 21 minus 3 would be 18. And then the other path from T1, T3, T4, or yes, that one was 19. So you would change the critical path. So it becomes a little more complicated, the answer, because this path is no longer a critical. But I try to keep it simple based on the numbers. You're decreasing task 6 duration by 1, you decrease the whole project's completion time by 1. This is critical path. If you expedite the critical path, you expedite the whole project. Anything on the critical path is delayed, the whole project is delayed. So I will save this one. Maybe I should say 0 here, and then put Chris's answer here. The whole project takes 1 day or less. And then I'm gonna save this as fall 2017 exam 1 critical path. A 2017 exam 1. So I can share it along with the video that we're recording right now. All right, I'm gonna go to fall 2017 exam 2, see what they have on their exam 2. Okay, I'm gonna share with that. This is just a random exam I picked. I asked you to work on fall 2019. I trust that you worked on that. This is too similar to your own exam. Or your own example we talked about in class. Let me ask this one. Let me start here. I'm gonna do this one. Okay, let's stay here. Everybody is able to see this burn down, burn up chart. I'm gonna put a circle here, and then everybody who gets a turn gets to, I don't think I can move that circle. I can do a text box clear, yes. Then I can put something around it, and it can go above things without covering them. How can I make it not cover? I think no fill. Yes, so go ahead, put this box around the area I asked you a question about. Okay, and I'm gonna ask how many? 4 of these. Instead of circle, you're gonna put a box around them. So go ahead. Let's go to the next one on my list. Chris has already taught Sassy. Circle or put a rectangle around the time that the team is going slower than the speed shown by dotted ideal progress line and mark it 1. Can you do that, Sassy? Put a box. Go ahead, take the box, put it around a time frame that the team is going slower. Yeah, just select, yeah, perfect. Make it bigger or smaller as you need. Be specific, just 1 time frame. You're covering 2 time frames. Yes. That's 0. Can you pick some place that team is working and it's not 0? Perfect. So you're going to the next, I think you wanted to do it here. So this one, yes. Yeah. This is 1. And I'm gonna make sure that 1 is visible. Yes, that's 1. And I wanted the formatting to, let's just keep it that way. That's 1. Who is ready to do the next one? I'm gonna go to the next one on my list. Look F. Go ahead. Circle a time frame during which the team is going faster than the speed shown by the ideal progress line.
Sure. Say here, and also say probably the next 2 segments also.
Just 1. You have to circle 1 of them. Perfect. Good job. So everybody is able to see that. Chris, look, while I'm formatting this one, can you explain why you picked that one? It's 2, actually. Look, F.
Yes.
Go ahead.
Yeah, I chose this one because the dotted line, you can see the slope, right? And then between the points, the 95 and the 63, it's steeper than the ideal slope. So that's why I chose it.
Exactly. So I'm gonna just save this file as Zoom and 420 2020 section 1. All right, perfect. Look, perfect. Sassy. Next question. I think I covered everybody going up and down. Everybody has answered questions. So Jake is going back to you. Circle a time frame during which some teamwork or some rework has been identified or the scope has expanded. Yes. So while I help you relocate that rectangle, go ahead, unmute yourself and explain what has happened here. This is 3. Jake, what's happened here? I think I picked this. I don't hear you. Are you talking? Jake, are you talking? I don't hear you. Matt, I'm gonna go to you, or let me see who is on my list. Jake, Nick. Nick, go ahead. Do the next one. Number 4. During the time frame shown in the following, oh, I don't have that. Is the team behind or ahead of schedule? In one sentence, describe why. I don't think you need to write something. Is it behind or ahead of a schedule?
They're behind schedule. They're above the like the ideal time limit, and you can see when they add it, they're even farther behind, and then they finally come and reach the end on time by doing a bunch more work than their projected ideal time.
Exactly. Okay, perfect. So these are the correct answer. You did it very well. 1, 2, 3. So you're gonna do the same on the exam, and probably you have to write between time. So this one between day 1 and 2, on day 2 basically. So let's go ahead, read this and do this for me. Remember we talked about this last time. I'm gonna give you 1 minute to work on this. Okay, I'm gonna go to Grant. Go ahead and start explain and writing the first step. What's the first step? Maybe I should give you one of these orange boxes so you can write in those, and then we can, when we share the file with everyone, we have it highlighted. So go ahead, write the first step. I'm not doing anything, it's you now. You can talk over your writing so everyone hears what your logic is.
The first thing I did is I added up all the sprints and divided by 6.
Yes. Go ahead, put the numbers in parentheses, divide by 6. You can scroll up a little bit so everyone sees the numbers. Perfect. Can you put them plus? So if everybody reviews this document without being here, they can know where you got them from. So just write 15 plus 10 plus 20, 15 plus 10 plus 20 plus 15 plus 20 plus 10 equals to 19. Parentheses close at the end. Yes, no, the before, yes, there. Then equals to 15. Perfect. That's the first step Grant did, because you're gonna, this is agile, you're gonna trust your team Make sure you understand what they're able to do. And the best thing is to have a look at their history and what they've accomplished. This is showing their velocity, the number of story points they completed during the past 6 sprints. You're going to take the average and you're going to use that. I'm going to go to the next one on my list, who is going to be Matt S. So go ahead, Matt S. Highlight in orange the activity, the user stories that you're going to pick. And I'm going to pick a, let's say yellow, but yeah, highlight in something. Here, I'm trying to control. You just give me a second.
Yeah, I'm sorry.
No, I'm just trying to find a good way to, yes. So the first story will go there because it's, then what else goes to your sprint? Go ahead, do that.
Yep. So it'll be the first 4 actually. Because if you add all these up, it'll be 3 + 1, 3 and 5, which will be 5, 8, 9, 10, 11, 12.
Yes.
You'll skip project or user story 5 because that'll put you over your average of 15, and then include number 6 because then that will be giving you exactly 15.
Perfect. Thank you so much, Matt. Why do you start at the top of your backlog?
Because those are typically usually the ones that are prioritized by
always.
your team.
It's exactly. It's not typically. Your backlog is always a list of prioritized features, user stories. That's the definition of backlog. You groom your backlog. Make sure you take your items out, add in, but whatever you add, whatever you remove, the result would still be a prioritized list. That's why we pick at the top. We don't want to overwhelm our team. That's why we skip number 5. And here, A, B, C, don't move my boxes because they have the answers beneath them. But tell me, write down there, Austin, which one is a schedule variance, which one is cost variance, which one is behind time. I'm gonna give you and everyone 1 minute. Austin, are you trying to write?
No, I'm just trying to remember because to be honest, I have no idea.
So there is this, okay, let me then stay here. There is this time, T2, let's call it T2. When you go up with a dashed vertical line, at T2, your earned value is here, your planned value is there, and your actual cost is there. This is at time T2. So you have earned value, you have planned value, you have actual cost. What was the definition of schedule variance? I'm gonna put one of those boxes. So let's just put the definitions. This is time T2. So what's the definition of schedule variance and cost variance? Who remembers that? Anyone who remembers, unmute and talk.
I believe it's for schedule variance would be the difference between planned and earned value, or sorry, yeah, earned value and planned.
Cost variance?
Yeah, that would be the actual cost and the earned value. So, but sorry, yeah, earned value, actual cost.
Austin, thank you, Matthew. Thank you, everyone. Austin, knowing this definition, does that help you?
Yeah, I could probably figure it out.
Okay, so time T2, you look at B, which is the gap between earned and planned. What is that?
That would be scheduled variance.
Exactly. A
And-
is the gap between planned.
Yeah, that would just be cost variance. And
Exactly. That's for T2. Exactly.
then that would be behind time, because that's all it's left.
That's all is left. Thank you. But also, if you want to, thank you. I'm going to get control back.
Yep.
Thanks for the work, everyone, and you, Austin. This is T2. When you look at what you earned, you're here. But your plan says you should have hit that point. When you do the horizontal line, your plan is saying you should have been at that much value at time T1. So time T1, you should have hit that point, but you are behind time. So a schedule variance tells you you're behind the schedule, but it gives you the value of the work that you haven't done. Behind time is actually talking about you're behind time. This is the time lost. That one is dollar value, not achieved. So well done, class. If I give you an example like this on the exam, and it has appeared on the exam so many times, I may not give you these 3 phrases. Okay, so make sure you have them on your cheat sheet, please. So next question is this one. This is going to be very long, so I'm going to keep that for the end. We did that. Let's do this. You've done the same example before, but let me see if it, just the first day we started doing anything in this after Corona life, we did weighted shortest job first. But maybe you forgot, so let's try to use it as a practice again. This will also be a question on the exam. So I'm gonna add one of those boxes that we used to write. And before that, maybe I asked you to answer the question before it. Go ahead, read the question before. And I'm gonna just make this box empty. So here, what is the answer here? I ask for volunteers. If not, I'm gonna ask someone to answer. If our average cycle time is 2.5 days per story, that's how much it's on average taking us to finish a story. Then what is the velocity of a 2-week iteration which has 10 working days? So we take on average 2.5 days per story. Now we have 10 days. How many story points do we get done? Let me see if anyone is interested in writing the formula. Ryan, are you interested? No? Luke F, are you interested in writing the formula?
Absolutely. Is it just the 2.5 days per story times the 10 working days?
Or something like that. You don't multiply them. So there is 10 working day. You divide it by 2.5.
Okay, so 10 divided by 2.5. So
exactly.
4.
Go ahead, write velocity is equal to perfect. 10 working days divided by 2.5 days per stories. So on average, you can get 4 stories done. Perfect. Okay, go ahead. Do the next one. Look, now that you feel like you can do this, and you can actually, so you showed that you can. So copy and paste the box, and then clear the box so you can use it.
Okay. I'm trying to paste here. Right.
So we got 15 stories in 10 working days. Cycle time is about time. So you put the working days, however many days you took at the top, and you divide it by the number of stories you completed to get the average cycle time. Average time it takes to finish one single story. So write cycle time equals to, so your time, which is 10 days, divided by 15 stories. Exactly, and equals 2.67. That's how much an average point, not 2, so 10 divided by 15. 0.67.
Okay.
Exactly. On average, thank you, Luke. On average, it takes a story less than a day to be done in your working iteration. Perfect. Thank you, Luke.
Mm-hmm.
So you're going to have an example very similar to this on your exam class, and you're going to do the same steps as Luke did. So we have the answer to these. What is missing? So we've done the other one. We're going to do this one. So first of all, I'm just going to, I think we had a table for this somewhere, but let's see what we did last time. Last time we did an example together, and I think we have a table that we can reuse for weighted shortest job first. Oh no, no. Just try to remember the concept, because I'm gonna ask one of you. 261 answered on Zoom. Let's see if this one has it. Just trying to be lazy with the table. And here I am, I got it. So I'm gonna put the table here, ABCBAC. So, and this is all the numbers, everything will be cleared. And I'll ask one of you or two of you to complete the table. But before we get the table, I need someone to just tell me what is the idea behind weighted shortest job first. I'm going to give the next one of you on the list. Ryan, go ahead. It's your turn now. What do we do in weighted shortest job first? You calculate a weight, and then the higher the weight, the higher the priority of the task. So the weight would be cost of delay that you see on the table divided by duration. So go ahead, write weight.
There you go. Oh.
Just Control Z. Weight. So, and then go ahead, enter, go to the next line. For A column, so A column, what is the weight for A? 10, which is the cost of delay, divided by 1 duration. That's 10. Go ahead, comma, B, column, what is the weight for B? 3 divided by 3 is 1. Perfect. Go to the next one. C, 1 is the cost of delay, divided by 10 is 0.1. So Ryan, if I wanted to prioritize this activity, I give the highest priority to the task with the highest weight. So which one of them would be the top priority here?
It would be A.
Exactly. And then?
B.
Exactly. And?
C would be last.
Exactly. Thank you so much, Ryan. You did the first part. I'm gonna go to the next on my list. So Ryan told us we should do A, B, and then C. And I'm gonna give you a random order. The random order would be B, A, B, C, A. So we're gonna compare these two in terms of the cost of delay that they would cause us. And for that, we had some steps. Jake, you haven't done this with us. Let's ask you to, or maybe I ask someone to do the first, I ask you to do the second one. So Nico, go ahead, do the ABC. If work in progress limit is 1, I can work on one activity at a time. A is completed first. The wait time for A would be
0.
exactly. For B would be the duration of A, because A is taking 1 day to finish and our work in progress limit is 1. So B has to wait for A to finish. That's 1 day. C has to wait for B and A to finish. That's 1 plus 3 equals to 4. So go ahead and do the cost of delay for each of them in the next column. That's 0 for the first one. For B is 1 times. Can you just write the times for the future review of this session? 1 times 3 equals to 3. 3 is the cost of delay for B. And for C is 4 times cost of delay for C, which is 1 actually. It's 1, Nico. No, 4 times 1. Cost of delay for C is only 1. Perfect. That's the duration is 10. Cost of delay is 1. Perfect. Exactly. And go ahead to the next row. I believe I have another row down there. Scroll down, see if you see the row. Yes, go ahead, write the total cost is 7. Exactly. Thank you, Nico. You did very well. I'm gonna go to Jake now.
Yep.
Let me move things up a little bit so we see everything on the same page. And yes, we see everything on the same page now. Jake, you're gonna compare this, which is Ryan's suggested sequence of doing activities based on the priorities that he discovered using cost of delay and duration. So what if we do B first? Wait time for B would be 0 because B is now the first one. C has to wait for B. B is taking 3 days. So the wait time for C is 3. A has to wait for B and C, 13 total, because one is taking 3, one is taking 10. Perfect. Cost of delay for B is 0 because there is 0 wait. C has to wait 3 days, 3 multiplied by the cost of delay, which is 1 for C. You get that from the table. And for A is the 13 times cost of delay, which is 10. 130. The total cost would be thank you, Jake. You did it. This is an exam question. Make sure you go over some other exams and see if you can do same activities again. Class, you see that the total was much higher for a random sequence than the one that Ryan suggested. Thank you, Ryan. Thank you, Jake and Nico. You all did very well. So we're gonna keep this and go to this question, a relatively easy peasy question. And this is about planning poker. If you remember Fibonacci sequence, it has to do something with the Fibonacci sequence. So I'm going to add one of my orange boxes here and ask someone to answer the question. Let's see, I can add my orange boxes anywhere. That's the beauty of the text box. So let's see who on my list haven't talked as much. Everybody has talked, yes, and I've lost a few of you. You're not. So, Sassy, do you want to give this a try?
Yeah.
Go ahead. So story A is taking 5, story B is taking 3, C 1, D 2. And we know the next story E is more complex than all the stories that we've seen here. What would be a number that we could assign to story E?
Maybe the highest number.
A higher number. So what would be a higher number in Fibonacci sequence?
I don't know.
So class, this is planning poker based on Fibonacci sequence because it doesn't have to be Fibonacci. The numbers go like this. Fibonacci sequence is 1, 2, you add the 2 previous numbers. 5 and 3 become 8, 8 and 5 become 13 and 21. So a number that you could assign to story E would be 8 or 13 or 21. 21 says it's too complex, it has to be broken up. But so 8 or 13 would be fine because it's saying this is more complex. This is supposed to be an easy question. I understand we played this game a long time ago, so that's why probably it was not as active in your memories as it would be by the exam time. But it's an easy question, so I'm sure you can do it. So this one, go ahead, give me your best explanation. Who is next on my list? Sassy has talked, Luke has done a few examples, Matt has done it. Nick R, give me your talk and write your best explanation. Examine the trend of WIP. Is the progress in work completed consistent with the WIP limit concept? In one sentence, that says one sentence. In one sentence or two, explain why. Be specific, provide reasons based on what you see on the diagram. Nick R, it's yours. Explain and just write a brief explanation. This is the example actually we used in one of our lectures before. So it can be based on your opinion. I cannot unmute. Why? You unmuted if you.
When we gain control of your computer, it makes it so that we can't go back to the Zoom and unmute. Like
Okay. So let me first abort control. So unmute yourself. I can write for you.
So is this talking about how essentially as we start and complete more work, we have like the more work that we have in progress and completed, the less we have in the not started? I guess I'm not really sure about this concept.
I'm writing something. So the work in progress should be limited. This concept goes along with pool system. Letting your team members, pool features, to work on when they are done with their current task. So,
so does that just basically mean as people are working and finishing tasks, to keep pulling more in to keep their like in progress work equivalent throughout the entire project? Limited, yeah.
Under control. So would you consider this project to be following that concept, the work in progress limit?
I think to a degree, because the in progress, I guess, section is fairly consistent. I mean, there's a little bit of it bows out at the beginning and tapers down at the end, but I mean, it's a fairly consistent in progress amount of work.
So yes, to a degree, they are fairly consistent, okay? And then you have to describe, because the same things you just told me. What can you explain that again, Nick R?
Explain like why it is a. So basically, as they start their work, I mean, they bow out a little bit at the beginning and take a little too much work, but they take an amount of work, and every time they complete a task and move it to that completed section, they pull more of the not started in to keep that started section roughly equal throughout the entire project.
That started color band or section fairly under control, or however you want to describe it. So an explanation like this would work. You just need to show me that you know what work in progress limit is. And I think Nick R has showed here. So we did this one. We did the story points and Fibonacci sequence. We did the weighted shortest job first. We did velocity and cycle time. We did the burn up chart. We did the velocity and team capacity and sprint planning together. We did this chart together. We didn't get to do this. So class, this is fall 2017. Exam 2, I believe. Yes, exam 2. Let me double check. I don't see the top of my screen. So go ahead and download the file, or after I post it on ReggieNet along with my video, work on it. I have a chat. Press Alt A. Oh, I didn't. So work on the earned value analysis. I did a few earned value analysis with you. I feel confident, but let's do this one more time. And the next time when I see you here on Wednesday, I can answer questions. We can focus on the areas that are sources of problem. Nobody wanted to talk. We're gonna do another exam just like this that covers all the areas that will be on the exam. So earned value analysis, critical path analysis, velocity, sprint planning, cycle time, Fibonacci sequence and planning poker, burn down or burn up chart, and cost variance, schedule variance, and behind time, that filling blank section on the chart, work in progress limits, weighted shortest job first. All are these questions on the exam. I'm gonna go over them again. So if you have questions, I'm here. If not, this video has to be processed. Probably at night, I will post it along with the file that we created together. Questions?
Can you remind me one more time the exam you said? I think you said fall 2019 is the one that we need to be focusing on.
No, this is, and I didn't tell you to focus on one over the other. But if you don't have time to look at every one of them or a few of them, just focus on fall 2019. But this one that I just discussed with you is fall 2017, and it seems very similar to your exam. So you can go back a few semesters for more examples of the same type of questions. So if you wanted to see more examples of a critical path analysis, that's the area you need to work more on. Go ahead, dig through the exam folder and pick the critical path analysis questions. In reality, sometimes I go back to my old exams maybe take a question and tweak it a little bit, because good questions that are small enough yet they're complex enough for the exam, it's not easy to come up with those. So I may pick one question that may look similar to a question that you've seen on an older exam. So going through older exams, it's only going to help you. There is nothing bad about it. But if you want to pick one, pick fall 2019. This one was fall 2017. Any other questions, class? No, then I'll see you on Wednesday. And if anyone wanted to show up on Thursday, you have your office hours. Any questions, email me. Take care. Stay healthy and safe. Thank you. Bye.
Yep, have a good one.
Thank you.
Thank you. Bye.